Hello, everyone. My name is Pedro Vidigal, and this is Carlos Rolo, and we are here to talk about the Cassandra B sides. So this talk is the lessons we learned and the mistakes we made while managing Cassandra clusters. So let's go for it. Okay, so I'm going to present Carlos. So he's a open source consultant in Pythian. He's deals mainly with distributed systems. He's a certified data stacks architect, also a Cassandra MVP, and basically started as a Cassandra DBA basically when Cassandra started. In 2011. And me, my name is Pedro Vidigal again. I'm the team manager for the Cassandra team at Pythian. I was for many years working in the dark side as an SAP consultant, so completely closed source projects. And now I'm basically leading the Cassandra team and designing and maintaining the Cassandra solutions for our clients. Okay, so what is Pythian? So Pythian is a consulting company based out of Canada, and we do have a lot of experience. So we manage around 11,800 systems currently. We have more than 500 consultants. We are basically we are distributed around the world. The main office is in Ottawa, but most of us work remotely from home or wherever we want, basically. And so we do have a lot of experience put all together. So let's talk about the mistakes we did and that we found while managing Cassandra. So what's the first mistake that we did, and this is basically one of the mistakes that we find very often in Cassandra, in our clients, in the first interactions we do with them, is that they start using Cassandra because either someone heard the buzzwords, they wanted to try it out, but more often than not, the use case doesn't really fit the Cassandra. So if you are looking into ad hoc queries, if your data sets are small, if you have a very relational model, then and again, if you need to be 100% consistent, then probably Cassandra is not the best fit for you. So in Cassandra, you actually do the things, the data model, you do the things the other way around. So instead of building your data model thinking about the properties and the objects you have, you do it, you start by thinking, okay, what are the queries I need, what is the information I need to extract from the database. You develop the queries, and on top of those queries, you create those tables to serve those particular queries. Again, small data sets, it's not really the strong point for Cassandra. You usually go to Cassandra whenever you have huge data sets and huge ingestions. We already talked about the relational model and about the consistency. Basically, since Cassandra is a distributed system, to leverage the Cassandra fully, you will want to have a cluster with multiple Cassandra nodes. And if you have multiple Cassandra nodes, it will be highly likely that the data will not be 100% consistent between all the nodes. So Cassandra, basically, the trade-off is consistency to ensure that you have performance and that you have availability. So It's very hard to kill a Cassandra cluster, even if you try. But this is what you lose, and you have to model and compensate for this issue. For example, the first project I did for Cassandra, I was doing a route optimization project, and while it made sense. So there were two parts of the project. One was data acquisition from sensors in vehicles, and that part made sense to use Cassandra. But in the routing section, it actually made more sense to use a relational database, and so to use an hybrid system. In the beginning, we started using just Cassandra, and so we came into a lot of problems because of this 100% consistency, and the problem that since you cannot do ad hoc queries, you either denormalize the tables and create a new table to serve that query, or you start running into performance issues. So, second mistake.
Well, I'm going to try without microphone. Everyone can listen. That's going to be tricky.
Yeah, that's nice.
Yeah. Okay. So don't paying attention about hardware. When we deploy Cassandra, we see one of the first things is you don't need really a lot of hardware. Cassandra runs on a lot of small nodes. That's actually a good thing. You don't need expensive hardware. You just need a lot of small boxes. But the problem is it cannot be any box. It's still something that people think it's like I can deploy it anywhere. While normally in other databases you deploy one, maybe 2, 3 instances, you take great care of where you're going to put your database. In Cassandra, this tends to be whatever cloud I can get, whatever server I have. Let's make it cheap and let's make it a lot of them. So the first thing that's really, really bad for Cassandra is the storage. Cassandra is highly sensitive to storage latency. So network attached storage like SANs, NAS, all those derivatives, even high performance SANs are a terrible choice for Cassandra. Also, especially with SANs, you have the thing that you get a single point of failure for a distributed system. It's not on your nodes, then it's on your storage. So it makes no sense. And we have failures because of this. The SAN fails, your cluster is out. Even if you have 100 nodes, it doesn't matter. So in the past, we tried to make it work in SAN. It didn't work. Latencies are terrible. You can get problems like several nodes writing on the same disk stripes, which it's unfortunate coincidence, but it happens. Then one single node can trash the other node disk performance. Really small nodes, I've seen deploying Cassandra on, even I did this on those micro instances, small instances, have tons of them. And then especially on cloud environments, you can get stuff like this, which is CPU steal by the other VMs on the group, because you are deploying on really small VMs. You have no guarantees of CPU that's attributed to you. And the brown is on this chart is CPU that is being used by other instances, not mine. So, well, my nodes were not performing at all. Spinning disks. This is a so-and-so. It still works as long as you're not demanding read-heavy workload. So, since Cassandra was made in 2008, one of the optimizations at storage level was for spinning disks. So they do sequential writes most of the times, but reads, well, that are random. So and given that Cassandra has a lot of background tasks that do put some stress on storage, you want to avoid spinning disks to again give Cassandra latency on the storage, and then it propagates all over the system. Bad networking is still a distributed system, so partitions might happen. And we have examples with multiple data centers where some data centers are really far away, for example, China. That latency still exists. So it's not, the replication does not happen by miracle, it does not teleport data over. So a bad networking, a flaking network will still give problems, will exacerbate the already beware of consistency problem. And this is often overlooked. Like I never seen, or mostly we don't see people take care about what networking I'm putting my nodes in, because it's still tolerant to failure, but up to a point, it's you don't want completely. And there's one thing, there's a background task in Cassandra. I don't know how many of you are highly familiar with Cassandra here, but there's a background thing called Compaction where Cassandra eliminates duplicates in data and rearranges data for optimal performance, and this can take up to 50% of your disk space. So normally having a hard drive with 70% usage is not bad. In Cassandra might mean you run out of space because this process kicks in and uses all the available disk space and your nodes crash. So take care of disk space and don't go really. I would say that if you want to deploy Cassandra, deploy at least on 4 to 8 cores, 16 to 32 gigs of RAM. Don't go really small on this. SSDs, if possible, they are cheap now. And instead of going tens of nodes, start with 3, 6. Don't go a lot of small nodes, go a bit in the middle. Less nodes, better nodes. Isto vai ser problema.
So this is so mistake number 3, and this is a little bit related with mistake number 1. So it's choosing the wrong data model. So Cassandra is not a relational database, and so it is very important you not to think like a relational DBA. We do have a lot of cases where this happens. So basically what happens very often is that we have a client that was using a relational database, and for some reason, and usually it's because the database they were using no longer is able to handle the amount of writes they were receiving, or if they want to basically if they have several geographical regions they want to serve, and when that's the case, or if the size, the amount of data is really big, then they start considering moving to Cassandra. But one thing that they usually don't do is that they don't really reconsider the way they were doing things and how they will need to adapt the data model to the new Cassandra reality. So in Cassandra, one main rule is we don't normalize. The Cassandra operates under the assumption that storage right now is cheap, and so you basically you have nodes, and if you need to denormalize to serve your queries, that's what you do. So if whenever you need to have a query, a new query, for example, in Cassandra you select by the primary key. If you would need to select from a table from one other field, what you would do in a relational database, you would create a secondary index and you would go and use that secondary index. In Cassandra that doesn't really work that way, because, well, again, you do have secondary indexes, but the problem with secondary indexes is that they are stored locally in each node. And so when the application requests queries the database, there's one node which is called the coordinator node, and basically any node can be a coordinator. This is like a random selection. So the coordinator node for that operation will, and if we are selecting using a secondary index, it will say, okay, let's fetch this information to all the nodes, and then this coordinator node aggregates the information, checks what is the latest record, and then it sends that information to the application. And this is very, very time consuming, and it's one of the reasons we have timeouts in Cassandra. So if you want to use secondary indexes, and there are cases to use secondary indexes in Cassandra, is if you have white partitions, and you want to select inside those partitions, because if you include the primary key in the query, the coordinator will know in which nodes the data is, and then it will only use the secondary index to filter that information. Okay, so if I were to give this talk probably 1 or 1.5 years ago, one solution I would give for this, for the secondary indexes and for the don't normalize rule, would be, okay, just use materialized views. Unfortunately, it's a great idea, but the implementation of materialized views didn't turn out exactly how it was planned. And this is due to the fact that this is a distributed system, and there's no guarantee that, again, imagine you write to the primary table, but there's no guarantee that record will be replicated immediately to the materialized views, and you can have one table and multiple materialized views. You don't have that guarantee. And again, you can have multiple clusters, and so you might be writing in one data center, multiple data centers. You might be writing in one data center and expecting that data to be replicated automatically to the other ones, but this doesn't happen immediately. So so what you need to do is basically you need to play with the consistency between the reads and the writes. So when you so basically you can select several levels of consistency. For example, if I write using consistency level 1, I only require one node of the entire cluster to acknowledge my write for me to consider the write to be successful. But this isn't really usually the way you want to go, and you usually want to use at least, usually a good rule of thumb is to use a consistency level quorum for reads and writes. Or if you're using multiple data centers, use local quorum, because you don't want to wait to have a node in another data center to reply, and that would take a lot of time. Also, fat partitions are sometimes a problem, because you should not. So whenever you have fat partitions in Cassandra, you run into the risk of creating hotspots in the cluster. And what does this mean? You usually consider the Cassandra cluster like a ring, and you would want the data to be evenly distributed throughout the ring, throughout all the servers. And this is because you want to have the optimal performance. If you have one data that is overloaded with data, or if you have like one node that is overloaded with data, and that might be data that is very often used, then that server is always being hit by reads and writes. And the other ones are like silently waiting for something to happen. And this is when nodes die, because the data is not evenly distributed. Counters is also a problem, not as much nowadays, but in the past it was actually a very big problem, because whenever if you imagine you use the counter, and if, for example, if a node died, you had it was often the case that the counter would basically the logs would be replayed in the server, and the counters would increase again, so it wouldn't be really they weren't really counting anything. Deletes in Cassandra, and this is the key point for Cassandra, and why Cassandra is very efficient in the writes, is that Cassandra is an append only storage. So whenever you're doing an insert, a mutation, a delete, it's always an append. The delete is it's an insert with a small difference. Basically, you have basically you have a timestamp saying, okay, this record has been deleted at this time, and when you are reading, the coordinator node checks all the records and say, okay, I have a tombstone for this record, so this is deleted, and it will be basically it's eliminated using the background jobs of Cassandra. This sometimes causes problem when nodes die in the cluster, is that you can have phantom data reappearing that was supposed to be deleted reappearing in the cluster, and that's why it is very important to have repairs, and basically repairs are jobs that basically ensure that the data is synchronized between each and every number of nodes. Just to finish off, there are other things that you should take care of, take into account in Cassandra. Is batches are often a problem in Cassandra. You do get into trouble and timeouts when using batches wrongly, so basically when they are too big. Number of tables, you shouldn't use too many tables in the same key spaces. Lightweight transactions, so Cassandra does not, so you should not, if you need transactional a transactional system, Cassandra is probably not for you. So you do have lightweight transactions which were implemented not so long ago, and they work, but the problem with lightweight transactions is that they rely in an algorithm called the Pax's algorithm, and this is basically it queries all the nodes to ensure that the data has landed in the nodes, and if that doesn't, and that takes a lot of time, and so this is one of the major reasons we have issues in the writes, which you should never have when using Cassandra.
So this is a mistake that's often a lot is Cassandra is always deployed with replication, normally to increase performance. Base replication normally is around 3. And there's a take that replication is a backup. I have 3 copies of the data, so I don't need to do backups. No, that's just wrong. Replication replicates everything. So if you drop a table, it drops a table everywhere. If you insert the wrong record, it inserts the wrong record everywhere. It does not have any weight mechanism, even across data centers. They are on. If the packet goes on the network, it's there. So you deleted the data, you inserted the wrong data, you changed the table. Your app has a bug. This is actually happened last week. Customer said, "Yeah, my app has a bug. Can we go back because replication, old backups?" No. If you don't have your backups, if you don't test your backups, it's gone. It replicates. Replicates all the mistakes. even across data centers. There's also a problem on the backup side is when you back up 3 times your data. So if you have replication 3, so you have a massive backup. So there are actually mechanisms, tooling on the backup side to try to avoid that. But it's, I would say this is actually one of the hardest problems in Cassandra at the moment is if you have really big nodes, like hundreds of gigabytes or terabytes of data per node, your backups will be absolutely massive. So this is so either commercial tools or a lot of scripting to avoid running into a massive backup. On the other side, the more you refine your backup, the more difficult is your restore. Because if you replicate if you pick, let's say, if you have 9 nodes, replication 3, and then you restore a single copy of your data, you back up a single copy of your data. When you restore, you have to make sure that you send the right data to the right node, otherwise Cassandra will not find it. Or you send all the data to all the nodes, and then you send a massive backup to everywhere, and then you wait for the nodes to trim out the data that doesn't belong to them. So replication is not backup, but backups are also not that easy. So, but always do it regardless. Especially if you're on the cloud, normally storage backups are pretty fast and easy, like EBS snapshots, Azure clone, and you can work with that. On-premises hardware, this is exactly the same as saying that RAID is a backup. No, RAID is not a backup. So it's a backup in case a disk fails. It's not. Replication is a backup in case a node fails. So another thing is, another mistake is we don't care about the operating system. We install Cassandra and we go. Cassandra is still a database, still needs to be taken care. There are a lot of problems. One of the biggest problems in distributed system is clocks. Cassandra has a last write wins policy. So if there is a simultaneous write with the same key, the one with the most recent timestamp will win. So if your clocks are not in sync, you see what you can get there. You can do 2 writes that are completely timed apart, and the old one will appear as the most recent because your clocks were not in sync across your cluster. And then when the nodes coordinate your reads, some node, even with older data, will tell, well, but my timestamp is more recent, so take my data. So this leads to a lot of weird problems in Cassandra because the error messages are not clear at all when you have inconsistencies on your cluster, because it will complain about everything except the clocks. So normally weird warning messages and apps complaining about consistency leads to the first thing I always check is clocks. Swap. Having swap enable is normally a thing. Cassandra is a Java application. It's made to use like half of your RAM, and it should be what it should be set to. So the heap size in Java for Cassandra is off. If you try to swap that, you'll kill the nodes. Besides, it's going to die really slowly while the swap is happening, and it's going to cause a massive problem because the node is still working, the other node still sits working, but it's actually not being able to do anything because it's swapping like 16 gigs or 32 gigs of JVM into the hard drive and then trying to swapping it back. So always disable swap, that's the thing. Linux limits resources usage. You have the U limits. They are normally lifted in all databases operations, and you should do it the same for Cassandra. By the way, if you use the package installers, deb, RPMs, normally this is all done by the package managers nowadays. Before it was not. So this is must do if you run with tarball installs. So if you prepare your installations using tarballs, take care of this. Don't run Cassandra as a root. I see this a lot. Of course, it doesn't cause problems as with permissions, but well, it's not a good practice. Use updated packages, including kernel, especially on the Red Hat distributions. Kernel tends to be a bit behind, and storage improvements normally benefit a lot Cassandra. So this is something that you should take care. Well, right now, the only kernel that's really bad for Cassandra is like 3.1 up to 3.2. After 3.2, you are fine. But it's and don't delete French files from your file system. See. Okay, so this is a thing that happens a lot. Normally, big deployments on big companies. Ops and dev are separated. Even DevOps is supposedly running the things. You still have DBAs, you still have developers. And one of the things is you develop in a single node environment, which things like it's not distributed. Secondary indexes work just fine in single nodes. Materialized views work just fine in single nodes. Those things suffer at scale, so they never are problematic in single nodes. Clocks are never a problem in single nodes. Also, the data sets are normally representative of what we have in production. And for example, if you're on a single node with a small data set, select star from table is perfectly fine in Cassandra. Well, then if you have a terabyte or gigabytes, 500 gigabytes distributed table, select star, you are in for a nice... the app does this, and then this is ops, like all the dashboards running on fire. The hardware is also almost the same. So nowadays we have SSDs on your laptops, and you have your Cassandra running on spinning disks. Might happen. So you expect your reads to be fast, and then on the production environments, your reads are not that fast. So make sure at least to get either the development teams aware of the problems of Cassandra, or create a QA environment that's kind of similar to what Cassandra is. It can be tricky. I can give you a suggestion here is what we've been done recently to avoid crashing into this problem often is restoring backups to QA environments. So we do two things at once. We test the backups, and we get a kind of decent Q&A environment. Of course, really big deployments, you have no way of doing this. Stress tests, it's also a good thing. The other problem that happened a lot nowadays is containers, especially Docker Compose. People deploy multiple. I will deploy a 3-node cluster, a 6-node cluster on Docker, and then they assume this is the production environment, and then, of course, it's not, even though production might be running on Docker containers on top of whatever, Kubernetes, but it's still, there will be differences. So be aware that works in dev, it's ops problem, is a thing in Cassandra given all the problems. Did we see any good thing about Cassandra yet? By the way, Cassandra is really good. This is the bad parts, the parts that normally people don't talk about. So
one good thing about Cassandra is that so we do manage services for Cassandra and other databases. And one of the hard parts of managing a database is that you get paged whenever a database system for a client is suffering. And we almost never get paged because
if a node dies, a node dies.
It's no problem. It's replicated, and if the cluster is well dimensioned, then it's really not. Usually, it's really not a problem. You can just restart the nodes, start a repair, and that's it. No dramas whatsoever.
We have clusters running for multiple years without
no downtime.
And not even big intervention. So that's the good part. At least for the DBAs.
You would say that, okay, but this is because the client knows what they're doing. But this is usually not the case. It's because Cassandra is really, really resilient.
So I didn't save. It's missing some bullet points. Okay, so but I can talk about this. So don't change configurations at random, please. Don't go. We've seen also cases, for example, Stack Overflow. Correct answers are actually quite wrong, especially if they are like people don't say what version they are running. It's like, I have this problem in Cassandra, how do I do this? And someone replies, do this. And then people don't say which version. And there are configuration changes that do completely different things between versions, because there was a big storage change, for example, between 2 and 3. So be aware of what changes you are doing. One of the good things about Cassandra, really good things, is it's distributed. It's multiple nodes. You can pick a node and do the changes there. The changes are local. Do the changes there. See what happens. If it works well, propagate the change. If it doesn't work well, you only trashed one node. Garbage collection is another thing that's normally changed really badly. Java garbage collection can be a problem. It's use half the RAM you have. There's a new thing called vnodes. It's not a new thing, but once you set with a number, keep that number. And well, that's it. Avoid massive changes at random on your configuration. What I would say is like pick a random node, use the distributed nature for your benefit. But this one it's saved. So another one is security. But Cassandra doesn't bring any, like on MySQL, for example, it's mandatory for you to create a user. Here in Cassandra now it works without users, without roles, without anything. Well, so please do that. I will say that all of our deployments mostly didn't add any users, security enabled. So not even like a user per app, a user per user. So also Cassandra, until the new version has no audit. So you should have users to at least know who did what. So audit is only coming on version 4. So if you want really to be aware of what's happening on your Cassandra, you should at least have the users isolated. Use also the iOS security features. For example, firewall, don't have everything open. Cassandra only uses 2 ports. Keep those ports open. If you should use SSL. Why I'm not saying you need to or you must have, is because honestly, managing SSLs correctly over really big clusters can be really messy. I don't know anyone who forgot SSL expiry and then the cluster goes offline, because you have to manage hundreds of SSLs. So if you use SSL, beware of that. Book like 2 months before that on your calendar that SSL is going to expire, because normally changing the SSLs it's a problem. And if you are on multi-cloud, VPNs, don't push information through the internet out on the open. Cassandra protocol is actually pretty much plain text, so it's easy to see what's going on the wire. You also have the Java JMX security. Don't forget about that. It's useless to lock Cassandra. If you don't lock the JVM, then well, they enter the JVM and do whatever they want on Cassandra. So okay, the last one. No, on this one didn't save the image. Okay. So the last one is monitoring. Cassandra is distributed. It's not normal to have. It's kind of hard to deploy monitoring. Tools were not immediately available. It's still a new database. And then you get a problem and you have no idea what happened. So, and also the wrong, what happened? Yeah, cloud saves. So there is a lot of tools, Prometheus, tools that work on MySQL, on open source databases now work with Cassandra. So deploy monitoring, get to know what happened. Well, set the alerts, test the monitoring, test the alerts. That's the use again the distributed nature to test your alerts. Destroy nodes, crash one node, and you can see the alerts firing on your monitoring.
Also, so on the logging side, just to, since it's distributed, if you can use tools like, for example, the Elk stack, the Elastic stack to monitor your logs, that is highly beneficial in Cassandra. So one end, what happens is if you don't have something like this set up, is that whenever you have a problem, you need to go to all the nodes or to a lot of nodes just to check the logs and to debug what happened. If you have the tools in place, monitoring, the tools to centralize your logs, it will make your life managing Cassandra much easier.
Any questions? You can use Cassandra, by the way. Still has a pretty good fit in a lot of places. Okay, thank you everyone.